All right. Grace, go on. What's the original problem for 92?
92 is x to the third plus 8x squared plus 15x is greater than 0.
All right, what do we got to do on this one, Tyler?
Factor.
Factor. Say that again.
A lot of x.
A lot of x. Good. Factor out a GCF of x. X squared plus 8x plus 15 is greater than 0. Then what, Tyler?
You can get from that x plus 5, x plus 3.
Good. X plus 5 times x plus 3 is greater than 0. And now where do we go from there?
Find zeros.
Okay, and what are my zeros?
0, -3, -5.
Good. X equals 0. X equals -5. X equals -3. Now you don't need to have a, intricate number line. You just need to put the points there. Make this 0. Make this -3. Make this -5. It will not include those points. And so it divides it into 1, 2, 3, and then 4 sections. You just got to pick a point in each section and then test it. So in this case here, what do you say, like -2? I can't use 0. No, I can't use -2. Wait, well, I got that ball backwards. What am I doing? That was awful. All right, this is -5. This is -3. This is 0. There we go. That looks better. Now I'm going to pick -7, -4, -2, and 2. And then plug those in. Well, I'm just going to do the factored form there. So whatever's out in front, that's -7. It's going to be a negative. -7 plus 5 is -2, which is a negative, and -7 plus 3 is a -4. Multiply those all together. They're going to be negative. How about -4? So it's going to be -4. -4 plus 5 is a positive, and -4 plus 3 is a negative. So we end up with a positive here. Plug in -2, we get negative. -2 plus 5 is positive, and -2 plus 3 is positive. We end up with all negatives in that slot. And then when I plug in 2, I get a positive, 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 all positives. And what do we want? Greater than 0? All right, so final answer, x exists from, what do we got there? Don't forget to get the zeros. Don't use your test points, use the zeros. -5 to -3, union, 0 to infinity. Okay. Questions?
So I noticed that with all the ones that we've done so far, after each has the first point, it always will start either negative or positive, and then it alternates between the two going forwards. So if we find the first one, is it always going to be like that?
Not always.
Not always?
A lot of times it will be just because of the ways, but not always. Because if you look at that last homework problem,
Okay.
it didn't do that. And if you understand, if you go back to the shape of the graph and you understand that, that's kind of what you're doing here. Because these have a multiplicity of 1. Well, if they have a multiplicity of 1 and they go through, they will. It won't switch if you have something with a multiplicity of 2, where it bounces. So you got to watch that. So if you end up with something like x plus 5 squared, and x plus 3, then you have to watch that. So I'm not going to say, yes, a lot of times it does alternate, but it's not guaranteed to alternate. Because what was that last one, 93? And that was what, x squared plus 2x plus 1 is less than 0, is that right? And then, so that factors into x plus 1 times x plus 1, which is x plus 1 squared is less than 0. It doesn't matter how you leave it. So when you test that one, -1 is the only zero. And so I'm going to pick something to the left, say -2, and something to the right, say 0. Well, it doesn't matter if I plug it in up here. -2 plus 1 is negative, times a negative gives you positives. And over here, it gives you a positive times a positive. So that never changes sign. What was the answer to 93? That should be what? No solution, because they want, where is it going to be less than 0? Okay, where's it going to be less than 0? All right, you done with everything? Okay. All right. All right, give me that pass back so I can sign.
What'd you say?
Bring me that pass back so I can sign you back to study hall.
Oh, he kept it.
You kept it? All right, well, then
he
just
told
head
me
right,
just to
just
head
head right there.
Okay.
All right, so then, and now if you know what's going on with the picture, it should make sense because that's a parabola that opens up and it hits at -1. That's the only x-intercept, so it should look like that. So if you understand what the shape of the graph is in relation to the sign chart, it should all kind of come together for that. All right, we got to go finish up section 1.6, which I call 3.7. Well, we're going to do the rational inequalities. A little bit, I don't know if trickier is the right word. Probably a little bit harder. Just got to be careful. But we'll go through a couple of those. All right, copy that down. All right, we're going to use the same concept. We're eventually going to get to that number line. We're going to do a sign chart, plug in values to see where it's positive or negative. For polynomials, we just had to find where it equals 0 because anywhere else it's got to be positive or negative. Similar here, similar, but we run into two cases. We want to know when the top is 0 because that'll be your x-intercepts. What happens when the bottom's 0? What do you like? Think of the graph. We get what? Cooper?
Asymptote?
Yeah, vertical asymptote. It doesn't exist there. So to the left of the vertical asymptote and to the right of the vertical asymptote, it has to be positive or negative. So we need to know where the numerator is 0 and we need to know where the denominator is 0. And then we do our sign chart. Okay? So we got to find the x-intercepts. Okay, so that's where it equals 0. And that's basically you let the numerator equal 0. So that's just x minus 3 equals 0. X equals 3. So to the left of 3 and to the right of 3, it's got to be above or below the x-axis. Okay. We got to find the vertical asymptotes. Find the vertical asymptotes. And that's where you let denominator equal 0. And then that's going to be 2x plus 1 equals 0. X equals -1/2. All right, now, if it's less than or equal to, then the x-intercept could be a solution. The vertical asymptote can never be a solution. Okay, it will never work because it's undefined there. It's not a point. Okay, it just separates the graph. All right, so we got to use those to kind of divvy this up. So 1, 2, 3, 4, 5. I'm going to let that be 0. And I'm just going to go by ones. Let that be 3 and -3. So 3 is a point, and I'm actually going to put a open dot there because I can't use that one, and -1/2 is a point. And put an open dot there. Since it's just less than, I can't use either point. But those are how I divide my number line up. And I need to pick test points in between. So I'm going to pick x equals -2. I can use 0 here. And then I got x equals, I'm gonna use 5. Okay, x equals 5. And I'm gonna use them into that original one, x minus 3 over 2x plus 1. And then again, we're just saying, I'm just gonna see whether I'm gonna get positives on the top or negatives on the top, divide them, see where we're going with that. So negative 2 minus 3, that's gonna be negative 5, which is a negative. 2 times negative 2 is negative 4 plus 1 is negative. Negative divided by negative is a positive. All right, so everything in here is positive. So I got that right there. And then I got 2 other sections to test. All right, 0. Plug in 0, and I get 0 minus 3 is negative. 2 times 0 plus 1 gives me positive 1, so that ends up being negative. So I got all negatives there. And now plug in 5 and see what you get for 5. And I get 5 minus 3 is positive, and I think I get 11 underneath there. Positive divided by positive, positive. So I got all that. All right, well, what do we want to know? We want to know where it's less than 0. Where it's negative, that's going to be from negative 1/2. Bless you. 2, 3. Negative 1/2 to 3. So same idea. We just got to check the numerator and we got to check the denominator. Okay? And then see whether it's greater than 0 or not. All right, copy this one down. So 2 over 1 minus 3x is greater than or equal to 1. Before you start, though, we got to do something before you get too far. It's got to be 0 on the one side because we're testing like the breakpoints. We want to know when it's greater than 0 or less than 0. So we got to make this a 0 over here. So you got to subtract 1. So you get 2 over 1 minus 3x minus 1 is greater than or equal to 0. Okay, so you got to do that first. Now you can't say figure out 1 minus 3x yet. You got to combine those two. Okay, you got to get them to be one fraction. So we got to subtract these. All right, how do I go about subtracting these? Or what do I have to do? Goal?
No idea.
No idea. Oh, I failed again. I'm trying. I really am. I'm trying. Lane, can you help out?
Not really.
Not really. Keep going, Jacob.
Multiply it by the denominator.
What's your end goal there?
You'll put, it's basically just like 1 over 1. So 1 minus 3x over 1 minus 3x.
Okay, we got to get a common denominator. That's what I was hoping to coax out of you. But this has to have a denominator of 1 minus 3x. But I can't just put a 1 minus 3x in the bottom. I'm going to put a 1 minus 3x in the bottom. I got to put a 1 minus 3x in the top. So that it maintains its equivalency. That's equivalent to 1. Now I got a common denominator. And now it's greater than or equal to 0. So 1 minus 3x is my denominator. This gives me 2 minus 1 minus 3x. Don't forget to make sure treat that as in parentheses. 2 minus that quantity. Otherwise, you're going to be messed up. All right, distribute that negative, combine like terms. What do I really end up with in the top? I end up with positive 3x. 2 minus 1 gives me plus 1 over 1 minus 3x is greater than or equal to 0. You can flip that around if you want. They're really close to each other, but they are not the same. All right, we just got to find where the numerator equals 0 and the denominator equals 0.
Why, instead of changing 1 to 1 minus 3x over 1 minus 3x, instead of that, couldn't you have multiplied 2 over 1 minus 3x by the same thing? So it would eliminate the denominator, and then it would make it 2 times 1 minus 3x. minus 1.
Talking about in the beginning?
Yeah, so rather than.
So hold on. So we got an audience at home. Got to make sure they follow what you're saying. So do what right here?
Well, after you subtract over the 1,
Okay.
so multiplying the 2 over 1 minus 3x
Yeah.
by 1 minus 3x over 1 minus 3x and turning it into,
Like that.
so it's just multiplying it by 1.
Okay.
So then that would turn into 2 times,
So what are you doing with this one over here?
but just multiplying one term by 1.
You're multiplying this by that, right?
Yeah.
Which is 2 minus 6x over 1 minus 3x quantity squared. Minus 1. I mean, this is what I'm hearing, but I don't know if that's really what you're telling me.
Never mind.
Never mind.
Yeah.
Do you know where he's going?
No, but I have a difference.
What's
Go
yours?
ahead, Rhonda.
In the beginning, why couldn't you just multiply it over the 1 minus 3x and then subtract the 2 and negate the problem?
Okay, so 1 minus 3x, 1 minus 3x.
Okay.
In a different sense, but.
Well, that's what I thought you were going for,
Yeah,
but you weren't telling me that. Like that?
Yeah, because wouldn't it just be the same if you subtract over the 2? It would just be
And so then you end up with, if I subtract that, it'd be 3x minus 1 is greater than or equal to 0, right?
I think that's what I was talking about.
Okay, here's what happens though. You now lose, because we got to solve this original problem. But that original problem has a vertical asymptote. In here, if you do it this way and you eliminate that denominator, you eliminate the vertical asymptote. And so you would have to make sure you make a mental note to test that later, which typically gets forgotten. So if you do that, then at this point, you're just going to say, well, x is greater than 1/3. But that's not the case because we got a vertical asymptote in there and we got a whole bunch of other stuff going on. So basically what you do is you take out a lot of the problem. Does that make sense? Okay. So that's a lot of times that's your instinct. Like, oh, let's just get rid of the fraction. Get rid of the fraction because we say we don't like fractions, get rid of them. But here, then that will get rid of what we need to check. Okay, what we need to check. So we got to keep it in there. We got to keep it in there. Like I said, in this case here, that'll give you that one case. And let's come back to it, see what ends up happening here, how it affects it. So what is our, where does the numerator equal 0? 3x plus 1 equals 0 at x equals negative 1/3. Okay, right? And then 1 minus 3x equals 0 at 1 equals 3x. X equals positive 1/3. So now those are our points that I got to test. And 1, 2, 3, 4. That's 0. I'm going to make 1/3 way out here. You don't have to negative 1/3 way out there. I don't want to just cram it all in there in one little spot. Now it can never equal the vertical asymptote. So I'm putting an open circle here. It can equal 1/3. And so these are kind of my break points now, my test points. So I got to test x equals negative 2, x equals 0, x equals 2, okay, for that. And now I got to test them back right up here. And I'm plug those in. So negative 2, 3 times negative 2 is a negative 6 plus 1 is a negative. Be careful, negative 3 times negative 2 is positive 6. So that's really 1 plus 6. So you get a negative. So that whole thing is negative. All right, how about from negative 1/3 to 1/3? Okay, plug in 0. Well, 3 times 0 plus 1 is a positive. 1 minus 0 is a positive. So that whole thing is a positive. And then how about x equals 2? In that case there, 3 times 2 is 6 plus 1 is 7. That's a positive. This will be a negative. So the whole thing is negative. All right, so where's that whole thing positive when we plug in? In between negative 1/3 and 1/3, but it cannot include negative 1/3 because that is a vertical asymptote. It can include positive 1/3. Now, what did we get over there? See, over there, that would actually been, we would have had everything to the right of 1/3 because it doesn't take into account the sign of the denominator when we plug in a value. So you cannot eliminate the denominator here. So if you were not sure what they were talking about, totally ignore them. Okay? So totally ignore them. But that's why that doesn't work. Okay. So negative 1/3 and 1/3. We good, Ryan?
No.
No.
The vertical asymptote is when you set the denominator equal to 0.
Yes.
So wouldn't 1/3 be the?
Did I do that wrong? Oh, I did it wrong. So yes, good thing I asked you. So it should be flipped, right? That should be
Yeah.
include negative 1/3. All right, let me double check here. So that's negative 1/3. So it can equal that, which would be right here. So it can include negative 1/3. It can't include 1/3. Oh man, you guys are gonna be all ticked off at me. And you people at home are gonna be really mad too. All right, so now I gotta flip that. That's wrong. And that's negative 1/3 to 1/3. There we go. There we go. Lane, now am I making sense?
I think it's making more sense, yeah.
Okay, all right, good. All right, we good there? Me, we'll see you. She's like, I'm tired of this. Gonna go home. All right, let's take a look at one more. All right, we're gonna run into that same situation, and here you don't wanna cross multiply, we don't wanna get rid of denominators, we gotta use those. Subtract over, so make this x plus 3 over x plus 1 minus x minus 1 over x minus 2 is less than or equal to 0. Let's make that. All right, well, Luca, I'm sure you wanna explain to the class how we get a common denominator.
You multiply everything by x plus 1 times x minus 2. Like multiply the numerators.
What am I multiplying the numerators by?
X plus 1 times x minus 2.
Don't need to do both of them. You might be right, but maybe I'm not hearing you correct. All right, what's going to be my common denominator down there? What do I need to add to that?
And x minus 2.
So I add an x minus 2 to this one. So what do I have to multiply that top by?
Just by x minus 2.
Just by x minus 2. Okay, so minus. So I got an x minus 2 here and an x minus 1. So how about that one? What do I have to multiply that one by?
X plus 1.
Good, x plus 1 times x plus 1. Cool, Road, does that make sense?
Yeah.
Yes? Okay, less than or equal to 0. All right, there's really no easy way around that. You gotta do a little bit of work. Do not multiply those denominators. Do not mess with that. Leave them in that factored form. You're going to have to FOIL though the numerators. Can't get around that. So we got a FOIL here. I got a FOIL here. And now it's all going to be just over. I can just make this over x plus 1 times x minus 2. But I got a FOIL and that gives me x squared plus x minus 6. I'm going to put that whole thing in parentheses. Minus, what do you get when you FOIL the top? Not too bad. It's just what? X squared minus 1. So x squared minus 1. So minus x squared minus 1. That we want to know when it's less than or equal to 0. Well, I still got to mess with the top. I still need to know when the top equals 0. I still need to know when the denominator equals 0. But I got to mess with it a little bit more. What does that simplify to? That simplifies x squared minus x squared is gone. And I'm left with x minus -1, which is -6 plus 1, so it should be x minus 5 over x plus 1, x minus 2. Okay, where the numerator equals 0, that can be an answer, not the denominator though. So numerator equals 0, that's going to be x minus 5 equals 0, x equals 5. Denominator equals 0, that's going to be x plus 1 equals 0, x minus 2 equals 0, x equals -1, x equals 2. So yeah, -1, 2, and 5. All right, so now you got to do your sign chart using those as your breakpoints. Now it can never equal the denominator, it can never equal -1 or 2. So let's go ahead and let's see what happens. And I got -1, I got 2, I got 5, and I need to test in between there. So to the left of -1, in between -1 and 2, in between 2 and 5, and in between 5 and infinity. And what are my test points going to be? Let's use, I'm going to use -2, I'm going to use 0, I'm going to use 3, I'm going to use 7. All right, go ahead and plug those in and just, I'll catch up to you here in a minute. All right, that's what happens with -2. -2 minus 5 is a negative. -2 plus 1 is a negative. -2 minus 2 is a negative. So that's a negative divided by a positive, which is negative. So all of these are negative. Now with -1, that's the denominator. That can never equal that. I'm just going to put a hollow dot. 0. 0 minus 5 is negative. 0 plus 1 is positive. 0 minus 2 is negative. In the end, that whole thing will be positive. So those are all positive. Can it equal 2? No, it cannot. 3 minus 5 is negative. 3 plus 1 is positive. 3 minus 2 is positive. So in the end, that's negative. All of those are negative. And 5, it can equal 5. And then what do I do? What do I get when I plug in 7? 7 minus 5 is a positive 2, positive 8, positive 5, positive. All right, so I want less than or equal to 0. Less than or equal to 0. Negative infinity to -1. Does it include that -1? No. Union 2 to 5. It does not include 2, but it does include 5. Right? All right?
Yep.
All right, you got it. All right. Hardest thing can be getting those common denominators. Just dealing with fractions. Okay? That's what's going on there. All right, page 155. You've got 4 problems.